in Smalltalk, you had sort of the whole system in a single uniform environment. Open the hood is kind of the analogy, right? Like, for the most part, you can drive your car and not care about what's going on the inside. But when it starts making a funny noise, you can open the hood and to some degree diagnose the problem yourself. Our existing languages and tools make this very difficult.
Isn't that such a huge failing, just the way that we currently do programming? Because a regular programmer could open that up and just read the damn code.
I don't think it's fundamental.
Patrick Dubroy is a software engineer and researcher who's had a really fascinating career. He's done a good mix of real life programming at high profile software companies and also some fundamental research on questions at the intersection of programming languages and human computer interaction. He's worked at Google on Chrome, at Lyft on autonomous driving, and various research labs, like Alan Kay's Hark and Ink and Switch. One really cool project that he's maintaining is Ohm, a library that simplifies writing parsers and compilers in JavaScript. He also just released a book on writing your own WebAssembly compilers, which is accessible even for people without compiler knowledge, but isn't afraid to dig into low-level details. I really hope you enjoy this conversation and check out the book in the description if you're curious. Hey Patrick, really great to have you on the podcast. Super excited to speak to you.
Thanks for having me.
Yeah, tell me a little bit about your background and your work. I think you worked on the Chrome team, right?
Yeah, that's right. So I spent 4 years at Google, 1 year on the Android team, and then 3 years on the Chrome team. Yeah, it was really interesting experience. So I was 1 year in Mountain View, got the whole experience there, working at the headquarters, and then transferred to Munich, which is when I switched to the Chrome team and worked for 3 years on Chrome in the Munich office.
Wow, cool. What was it like? It's like low level C++ stuff, or what is it? Are you actually
Um,
doing when you're on the Chrome team?
So I myself did a mixture of things. So I for sure wrote my fair share of C++ code, but I always had an interest in doing more kind of high level stuff, more UI development. There weren't a lot of people in the Munich office who did that. I kind of became a bit of a jack of all trades, helping out on various projects where, certain features in Chrome that needed some UI support. I ended up working on those things and did a fair bit of work on Mac OS. So, doing a lot of Objective-C at the time. The core of Chromium is C++, or at least it was when I worked on it. But then, the Mac OS front end had a lot of Objective-C. And the other thing that I did was I ended up working on a lot of the features that were based on web technologies. So the history page, for example, was one that I did a lot of work on. The new tab page as well. So there are a certain number of features that are built with, JS, HTML, CSS, and I worked on those features as well. And it's kind of interesting because when you're writing UI using JavaScript and CSS, but you know that you only need to support one browser, right? Because this code was like shipped with Chrome. So you knew that as soon as a feature was enabled in Chrome, you could start using it. So it was basically a very different experience than,
Mhm.
most web developers have.
That sounds nice.
Yeah, exactly. It was very pleasant compared to kind of dealing with different versions of the browser.
I can imagine, yeah. And then after you worked on Chrome, you went on to work at some other really interesting companies, right? I think one of them was SourceGraph.
Yeah, correct. So I guess I've kind of done this almost a TikTok sort of thing in my career where I, at times, work in industry really, and then have taken a few years to do stuff that's a little bit more researchy. So immediately after Google, I had 3 years working in Alan Kay's research groups. So CDG and Hark, and then after that decided that I was kind of too far away from the real world again, and worked at Lyft on mapping, and then at SourceGraph as well.
Hmm. That that just to me it sounds like a dream career. Honestly, like this going back and forth between like doing research and then actually like implementing that research. I mean, I know maybe it's not exactly the same things, but that that's really cool.
Mhm.
That's a really cool career path.
Yeah, I really like kind of, I guess I see it as sort of a different focus where, in when I was doing the researchy things, I wanted to not be focused on the realities of the real world to some degree, right? And to kind of be in a mode where I'm thinking more about what's possible. And then after a few years of doing that, I always end up feeling like I'm getting too far away um, from kind of the realities of of software development, and have always enjoyed then diving into some very specific thing. And I guess another thing I've done over my career is kind of shift from different focuses. So, I really like learning new things. Like many software developers, it's not super uncommon, but I do enjoy kind of throwing myself into unfamiliar areas. So when I started at Lyft, after, the 3 years of largely programming languages research, I was working on mapping. And so mapping for autonomous driving. And this was a totally new world for me. I mean, I had a little bit of background in kind of the basics of computational geometry, and of course I studied computer science, so I had done linear algebra in my undergrad and things like that. So I wasn't totally unfamiliar with what was required to do mapping. It was still a very different world. And yeah, it's really nice, I find, to just immerse yourself in a particular world for a few years and then learn about all the things that are important in that world. And then um, usually I find after a few years that I want to take a step back and reevaluate kind of what I'm doing and what I'm focused on.
Hmm. When you say mapping, do you mean like what exactly do you mean in the space
So
of
it
autonomous
was
driving?
Yeah, so it was, I mean, we call it HD mapping. So it's basically the same approach that, Waymo pioneered, I guess. I mean, there were others, but Waymo was kind of the company that, and back then it used to be a part of, it was, at first a secret project at Google. And I remember being in Mountain View actually when that even got unveiled to Google employees. But anyways, the whole approach is that you build up a 3D model of the area that the vehicle is going to drive in.
So
Um,
it's like a VSLAM kind of thing.
so VSlam would be Visual Slam. We were not doing Visual Slam. So the team in Munich was focused on Slam, but based on LiDAR. So very roughly, you drive a mapping car, first of all, on the area that you plan to drive, right? And this is, similar to a Google Maps vehicle, something with 8 cameras on the roof and a LiDAR, which is, consistent or like constantly spinning, sending out laser, and building up. The laser is hits something at some distance, and in the sensor data you record, okay, there's an object here. What you end up with is a big point cloud, and then yeah, later when you go to drive there. So I mean, this map, what we call the HD map, is really, um, I mean, it depends a little bit on how on the specifics of how everyone does it, but largely you can think of it as kind of a bunch of voxels. So a 3D map of the worlds. And then you also want to know things like where are the lanes in this world? So really the approach, at least as we were doing it, and what was state of the art kind of, I don't know, 8 to 10 years ago, was, you've exhaustively mapped the world. You know where all the lanes are, you know where all the traffic lights are, The only thing you have to deal with are the obstacles, which means cars and people generally. Um, but for the most part, you can drive like if there were no cars and people, you could drive these routes with no cameras. And that's sort of a little bit the dirty secret of autonomous driving. Um, and I remember that's the thing that struck me the most when I first heard about the project at Google. So when I was working in Mountain View, there was kind of rumors or people said like, oh, there's self-driving project, and you would sometimes see the cars around the campus. But I didn't really know any details. And at some point there was a kind of unveiling to employees to tell them about, yeah, what was called Project Chauffeur. And this eventually morphed into Waymo. Um, but I remember being struck, like, when they were on stage explaining how it works, right? That they, oh, first we drive around and we exhaustively map the area. I thought, oh, that's it. Like, oh, now I see why this is actually tractable, why we could do this. Whereas before that, if you had asked me how you would make an autonomous vehicle, I mean, I would have thought it was much more of an AI problem than it truly is.
I worked at a company where we tried to solve a very similar problem. We were doing indoor navigation, and we also we did some stuff with lidar, but at the end of the day, we wanted to sell it with like regular mobile phones so that you can use it with regular mobile phones. So we just had pure VSLAM at the beginning, and then later we switched to ARKit and like the built-in AR libraries in the devices. But yeah, it's a really challenging problem, right? Because matching up those point clouds, when their environment changes and stuff, it's so difficult to get that to work robustly.
Yeah, absolutely. I mean, I remember there was so our with Lyft, all of the vehicles that we actually drove were in Palo Alto. So we didn't have any here in Germany, but there was an office of with we were, I guess, up to about 25 people or so working here in Munich. But all the vehicles were in Palo Alto, and there was this one place where we drove that was really just a field. Like it was a road going through a field somewhere, up behind Stanford campus. And at some point they cut the grass. Like basically it was really long grass. And then we
Oh
had this
no.
bug. We had this bug that, the car wasn't localizing properly. And yeah, it turned out it was because they cut the grass.
Right.
Because there was no buildings there, right? If you have
Yeah.
buildings, if you
Yeah,
have,
yeah.
our SLAM system, as long as you had, a sufficient match would be fine. And I think we had trouble at times with leaves as
Yeah.
well. Now, Slam wasn't really my domain of expertise. The team that I was working with, like basically, I joined as kind of engineer number 4 in the Munich office here. Three of the people were Slam experts who had come from Google, so they also worked on indoor Slam actually. Um, Google had an open source project called Cartographer. I don't know if you ever ran across that. But it was a LiDAR SLAM project, yeah, that was designed originally for indoor navigation. And the folks I was working with, modified that and turned it into a system that could work on cars. I was mostly building visualization tools. That was kind of originally why I joined the team. And in the process of building the visualization tools, you kind of have to learn about all the different parts of the system
Yep.
anyways.
Yeah, yeah.
So yeah, and then I kind of just really enjoyed mapping in general. I think there's something really fascinating about um, problems that involve representing the real world on a computer. Um,
Yeah.
and so, yeah, I really enjoyed that.
Yeah, I can see that. I think you have a pretty unique perspective here because you, on the one hand, like you've done both sides kind of, right? On the one hand, you've been on this fairly low level side, like working with compilers, stuff like on the Chrome team, I guess, right? Working with compilers, interpreters, and also like you've also done the human computer interaction side where you're much closer to the humans.
Mhm.
And I guess that also fits with what you said before, right? Where it's kind of like you like to switch the focus between those things. Is that true?
Yeah, absolutely. I think that's almost another axis that you could switch on, but certainly, yeah, I in my undergrad got kind of really interested in programming languages. I We had a third year course where you learn Prolog and Scheme. And I think that was my first exposure to kind of programming languages that are a little bit outside the mainstream. I mean, those are still pretty mainstream, but if all you've done is Java and C++, right? Those are pretty eye-opening languages. Then I got later really into Smalltalk. I had a compilers course where I decided to teach myself Smalltalk and write my compiler in Smalltalk.
Cool.
And then I ended up my first kind of real job out of university was actually working um, on this team at IBM who previously had built the Smalltalk IBM Smalltalk implementation, and then they were working on the J9 Java VM. And I was just really into language implementation. Like I think it's kind of fascinating when you've only ever operated at you've written code in high level languages, learning how the other side works is really interesting. And so for a few years, I was really into that. But I think, yeah, at some point I found, the low level stuff to be too disconnected from the human side of things and made a decision that I needed to make a change and went back to school and did my master's then in human computer interaction.
Cool. Cool. I think that's so cool because I think people like you in that regard are quite rare. I think you have a lot of people who are on either side of the spectrum, but I think having that overarching view, I think it's super valuable, and I personally think it's also just incredibly interesting. So that's really cool.
Yeah, I find it really interesting the way you can take, insights from kind of one side and apply them in the
Yeah.
other,
Hmm.
right? So it certainly gave me the ability to do things, to be sometimes driven by the human problems, but the ability to kind of go really deep in the stack
Yep.
to
Hmm.
address those issues. One example I remember when I was on the Android team, so I came to Google through an acquisition, and we were a small company who was acquired, and we kind of got put in charge of the Android home screen. Um, so basically on all Google devices anyways, the app launcher and widgets in the home screen. And we were working on the first Android tablet, which was the Motorola Zoom, which was this pretty clunky tablet actually. Um, but and we had this issue that certain apps that were image heavy. So I remember the YouTube app used to be one that had a lot of issues because it had like thumbnails for all the images. If you rotated it, too quickly, you would get an out of memory error. So basically, I mean, even understanding what was going on there, the fact that I had worked on a Java VM was super helpful because it was related to finalization and the way that the backing data for the images wouldn't get. I mean, it was freed through a finalizer, and that meant that basically, um, yeah, it's sort of finalization in Java VMs is kind of asynchronous, and so you can't do a single garbage collection and clear up all the objects that can be finalized for for reasons. But I was able to go in and fix this problem because I already had an understanding of, the low level, what was going on at the low level. And I think most people who are UI engineers wouldn't necessarily be able to go down and make a fix in the VM. But, I went into the Dalvik VM and changed the way that images were, or the backing data for images was allocated. And it was a huge win for users, right? It meant that you weren't, because on Android, if your app gets killed, it's not a great experience.
Yeah. Yeah.
Yeah. So I think over the years, this ability to kind of go back and forth, also on the low level side, to be able to think about, the usability side of things, this has been super beneficial for me. And so I've always liked kind of knowing a little bit about those two worlds. Um, and now that I think of it, it's not all that much different from. So I grew up in Canada, but have lived in Germany for the past 13 years. And there's something similar there, that you kind of know two different cultures and it helps you kind of understand, what are the things about one culture that, or maybe there are other ways to look at the world. That's, I think, a really valuable thing to have.
Hmm. Do you struggle communicating that to employers, or is that something that is easy? Because I I have had the experience that sometimes it can be quite difficult because it's kind of like a very generalist approach to things,
Mhm.
right? And I've had the experience that this can be a bit difficult to communicate. Is that something
Yeah,
you've
I
also
think for
experienced?
sure. I think everyone, people generally want to slot you into a particular box. Are you a front end person or a back end person? Or, people say full stack, but even full stack doesn't really mean full stack. It typically means, web back end, web front end. Um, so yeah, I've certainly had challenges with that. But overall, I can't say that it's been, a big problem. I've probably gotten more benefit out of being a generalist than I have had issues with it.
Hmm. For that project that you talked about before, what what were you actually hired for? Was it more the low level side, or was it actually the more user facing side?
On the Android team,
Hmm. Yeah, with the.
yeah, I was I was hired really for the more user-facing side. So we were kind of I worked at a small startup. It was called Bump Top. We built this 3D desktop that replaced your regular Windows desktop with a 3D physics-based desktop. And yeah, we got acquired by Google because it was kind of a very innovative user interface concept. Got a lot of got a lot of buzz at the time. My friend, the founder, had done a talk at TED, and yeah, and so we got brought in largely to be kind of UI engineers. And actually, I remember quite well too that um, we were all people who kind of saw ourselves as kind of part designer, part engineer. And we ended up, when we were on that team, we hung out a lot with the design team. So I still have some friends from that time that were designers on Android. So yeah, I absolutely wasn't, I don't think anyone would have expected that we would be working on the Dalvik VM. Um, but there were other people on the team, certainly, who kind of had a similar breadth. Not everyone, but I think, um, yeah, the team certainly had some very strong engineers, people who could kind of go up and down the stack. So it wasn't, I don't think it was, at a company like Google too, right? It's hard to do anything and really stand out because there are so many amazing
Smart
people
people. Mm.
uh, there. So, but yeah, I don't think anyone expected us to be making changes to the VM.
What drives your current research interest?
It's a good question. I think a few different things. I mean, I guess a lot of my research is driven by this tension. Not sure if tension is the right word, but I mean, I've always been really interested in design as a discipline. And so before I even got into computers, really, I was really into industrial design. And then when I graduated from high school, I originally thought, oh, I'm going to go study graphic design. Um, and for me, one of the most interesting things about design has always been having to make hard trade-offs. So kind of, you've got this solution space, and I always felt like if there's an easy answer, then you're not really doing design. Um, and so I think I've gravitated towards this middle ground between sort of the low level concerns and the high level concerns because of that, because I really enjoy these really difficult trade-offs. Um, so I think like when I first started kind of working on more, um, I guess, what you might call sort of future programming ideas, I was very much into kind of trying to rethink everything, and think like, okay, from a totally blank slate, what would programming look like? Um, and I think now I'm much more interested in that hard middle, which is like, okay, let's take some aspects of our computing environment as a given, right? And let's look at what the human needs are, and it's really hard, but let's try to find kind of that those clever ideas that kind of marry those two things um, in a good way. And so, I mean, that's a very high level way of describing it, but I think this is why I've kind of ended up, I think, always so interested in programming languages, because it's really at that boundary between the human and the computer. Um, and so, I've done some of the things that I've worked on recently were kind of learning how to program GPUs. Um, and so, one could say, oh, yeah, the way we write shaders is totally wrong. There are much better ways we could do it. And while I find that to be true, I actually find it more interesting to kind of say, okay, let's take it as a given that we have this hardware that can do a certain thing. And let's figure out how we can use that. What can we make? How can we make languages that expose the power of that hardware in a way that makes sense to people?
Hmm. I
Um,
see. Hmm. So not completely reinventing the wheel, but taking the constraints that of the world that we currently live in, basically, and seeing how we can make the best of it and how we can get that closer to what people would actually need.
yeah, I think so. And just in general, looking at the current ways of programming, and still, looking for the problems and looking for the ways that we can solve the problems. But yeah, I think that's a big difference compared to what my research interests were 10 years ago. I would say that today I'm much more accepting that, there are good reasons. Well, it doesn't matter whether they're good reasons or bad reasons, but the world is the way it is.
It is how it is. Hmm.
And
I see.
we can change things at the margins. And yeah, I'm interested in that margin really,
I see.
much
Hmm.
more than trying to kind of reinvent the whole structure from scratch.
Hmm. I see. I see. I mean, I guess it comes with age, right? I guess.
Yeah, perhaps. I mean, yeah, I think so. You can be very idealistic when you're younger and believe that more wild forms of revolution are possible. And maybe the older you get, the more you realize Yeah, that I mean, if we rebuilt things from the ground up, we would have a different set of problems, right? I think many people are familiar with second system syndrome.
Yep.
Um,
Yeah.
it's something that happens over and over that, you find something that's totally broken and you rewrite it and you get a new thing that's totally broken in different ways.
Yeah, I think it is worth sometimes to do these really big revolutionary changes,
Yeah.
but it always takes a very long time to see if it actually was worth it.
Yeah.
But let's actually get into it. So you mentioned before trade-offs. You're interested in design space and in trade-offs, and also you mentioned that let's focus on the problems of programming today. What do you think? What are the problems of programming today, or where are the interesting trade-offs in your opinion?
Mm, yeah. Um, I so I mainly think that we're still missing some good abstractions or good, I think there are certain concepts that we lean a little bit too heavily on. Um, as a specific example, I wrote a blog post a few years ago called Three Ways of Handling User Input. I think it was called. And really, I was writing some code, where I was writing some callbacks to deal with, clicks on a button or something. And I just realized how error prone it was. And I thought, this can't be like, how is this still the state of the art? Um, and that led me to discovering there's this concept called structured concurrency, which I think is a very powerful concept. And so I think these sorts of ideas, I kind of feel like there are probably many more of them that need to be uncovered. And once they're uncovered, it takes a long time for them to be popularized. Um, so yeah, I'm often kind of in search of those powerful concepts that are kind of not yet well known. So I really enjoy reading, academic papers that come out by people who are kind of um, pushing the state of the art, and especially people who are kind of, outsiders to the existing system. There are some people who can really, yeah, really publish really interesting things that can change the way you think about programming. Jonathan Edwards is certainly one of them, and he's, for me, actually a big inspiration, and one of the reasons that I kind of ended up doing the research that I did was, like you, I was a big fan of his papers and really appreciated how they were approaching things from a very different perspective.
Yeah, that his stuff is really cool.
Yeah.
But can you do you think you can, maybe this doesn't work so well in this format, but do you think you can explain like the gist of what is different, like from the blog post that you just mentioned about handling user input? Can you explain the gist of what's different from the standard callback? Like the standard way of your handling user input would be like, in JavaScript, you have an event that gets emitted and then you just get a callback when the event is emitted. And then you can do stuff like a click event or whatever,
Yep.
right? What's the problem with that? And what is better? What could be improved about it?
Sure. Yeah. So in the post, I have a very simple little example of a box that you can drag around. And the idea is, you should be able to drag it and drop it somewhere. And you should also be able to drag it and hit escape and have the drop canceled, have the drag canceled and have the object returned to its original position. When I wrote that up, even the demo that I wrote up for the post ended up having a bug in it that I wasn't aware of.
Whoops.
And yeah, I think like basically the problem that I see with callbacks is you end up handling a bunch of different events, and you have in some sense a state machine. But the way the code is structured doesn't make the dependencies of the states very clear. So it's very easy to kind of look at some code and go, yeah, that looks like it's doing the right thing, but not be aware that there's a bug in it. And yeah, it was kind of ironic that even when I wasn't trying to write a bug in the program, I ended up putting one in there. And structured concurrency gives you a way that I personally think that just by observation, by reading the code, you can see the structure and the dependencies much more clearly. And so the structure of the code kind of matches the structure of the desired behavior much better. You can get something similar with, say, state charts or something. I think if you drew it up as a state chart, you would also see kind of where the bugs are. Structured concurrency is kind of a way to represent many of the same things that state charts can, but in something that looks more like imperative code. And yeah, so my feeling was that that structured concurrency really was just a much better way to represent simple kinds of event handling problems like the one that I presented there. Not all event handling suffers from this necessarily. Like I think, you have to get into a certain amount of complexity before you start to see the problems. But yeah, and I mean, I think if you look at the academic literature too, people have been talking about this for, 20 or 30 years that, callbacks are not a great way. There's a bunch of other problems with callbacks. I would say memory leaks was is another big one that people kind of have an event handler that closes over some large object that they don't really intend to retain, and they never remove the event handler, and you end up with sometimes with a large chunkier object graph that can't be garbage collected.
Basically a retain cycle, right?
Not a cycle, because garbage collection can deal with cycles without trouble, but you're
That's
actually
right. Yeah, that's right.
yeah. So like retain cycle would typically, I mean, at least my understanding would be, in a reference counting
Yeah,
system
you're right.
where
Yeah.
you have kind of two objects,
Yeah.
or a cycle of objects, which
Yeah.
kind of are an island. And I mean, so the term garbage collection is a little overloaded, and
Yeah. You're right. You're right.
for some people, it means what I would call automatic memory management, which would include both kind of tracing, garbage collection, and reference counting.
Yeah. That's the old debate if reference counting or automatic reference counting is actually garbage collection or not, right? Some people say it is, some people say it isn't. But yeah, you're right. I was caught in my iOS days of
Right, yeah.
reference counted environments. Yeah.
Yeah, it's just I mean, those are also problematic, but it's a different
different
sort
problem.
of problem. Yeah.
Yeah.
This used to be worse in JavaScript when the JavaScript engines used to have kind of less sophisticated ways of retaining the environments, and it would often be the case that all of the local variables were in kind of one environment entry. And if you referenced any of them, all of them would be kept alive. I think these days that's not generally a problem. But back when I was on the Chrome team, um, that was a common sort of bug that you would see people complaining about a problem with the garbage collector. And yeah, it was quite often due to something that they had kept alive unintentionally.
Right. Have you I think it's also part of that blog post if I remember correctly, but you're also familiar with functional reactive programming, right? Because that's another proposed solution to the callback problem, right?
Yes, exactly. And I have an email that's been in my inbox for 2 years that I've been meaning to respond to. specifically about that blog post and functional reactive programming. So the authors of Flapjacks, which is an FRP system for JavaScript, sent me a kind email telling me that, it's not an unsolved problem. Flapjacks solves it. Um, my opinion, I don't know that I can make a fair criticism of FRP, but my opinion is that the FRP solutions to this are they're missing that property that when I look at them, they're obviously correct. Like I look at them and I think, yeah, much like the callback solution, I look at it and I go, yeah, I believe that this works. But I think structure concurrency, for me at least, I don't know if it's just kind of individual differences. Um, I think like the FRP solutions to me are harder to really grok and harder to visually see that, yeah, this is correct or not. It's not the same as FRP, but at SourceGraph, we had a lot of RxJS that was used, and you see some of the similar problems. I personally think certain things are data flow makes sense for certain things, and control flow makes sense for other things. Um, and I happen to think that these problems that I'm talking about in that blog post are better represented through control flow, personally. And I think the data flow solutions just, yeah, to me, aren't as clear, aren't as easy to understand.
Yeah, yeah, I've thought a lot about this problem. I once did a really deep dive into functional reactive programming because I found it really fascinating. I still find it quite fascinating, and I think it's a good solution for some things. But like, have you ever read that paper Out of the Tar Pit? Are you familiar
Yes.
with that one?
Yeah.
I really like that paper, and it differentiates between essential complexity and accidental complexity, right?
Hmm.
And the basic gist, oh, I hope I can summarize this in a quick way, but the basic gist is that essentially everything starts with your data model. Like, everything starts with your data model, and then everything flows from that. And it's that classic thing where, like, show me your data model and I'll know what the rest of your code is, right? But if you show me your loops or your control structures, then I won't really fully understand everything until I see the data model, right?
Hmm.
The old Brooks quote. And in this I really like this paper, and I agree with a lot of the stuff in it. But I think there's like a footnote somewhere in the paper saying that this model probably doesn't work so well if you have a program that deals with state changes that involve the current state of the program plus new user input that comes in.
Hmm.
And then they hand wave it away and they say, well, but we think this doesn't happen so much for most programs. And I think that footnote, that piece, is the key, though. I think I disagree with them that it's not most programs. I think most programs have this aspect where you have some pre-existing derived data that's based on previous calculations, and you have some new user input that now also affects the derived data in some way. And I think this is the part that the FRP model struggles with, because then you have to be able to model this correctly in an FRP way, you need to have a cycle in your FRP dependency graph. And a lot of, like, for example, I think, correct me if I'm wrong, but I think RxJS, for example, does not allow cycles in
I
its
don't remember.
dependency graph. So you can't even model this type of problem with something like RxJS, at least not without, like, I think there's some escape hatches that you can do to model this, but not in like the proper side effect free RxJS way. And that means like, and even your simple example from your blog is something that fits this problem, right? So even that is something that you can't actually model with this FRP stuff, at least as far as I understood it.
Yeah. And I think this problem even crops up in places where you wouldn't expect it.
Yeah.
So I'm reminded again of my mapping days. And one of the big mistakes we made was designing an architecture for building our maps that was, we kind of, at some point someone said, oh, this is really just a compiler, right? It takes in a bunch of, sensor data and produces a map at the end. But one of the problems was that we also had a bunch of data curation that happened. So one of the inputs to the map was OpenStreetMap, and we had a team of data curators who would look at the map data and they would see it in situ. So they would see the OpenStreetMap data overlaid on our 3D map and could confirm, are these lanes placed correctly and stuff. And we built this architecture as if it was going to be one big, batch computation. But we discovered, well, we end up discovering problems at the end of the process, and we need to go and we need to rebuild the map with just a few new inputs. And, it becomes an incremental computation. And we realized that we had made kind of a pretty big architectural mistake by conceiving the whole thing as a batch process. And if we had been thinking much more like a real-time user interface, we probably would have ended up with a better system. So even in a thing that's not obviously a UI, you can have this problem that, yeah, you actually need to have some of your inputs which depend on your original output. Um,
And at the end of the day, it's a cache invalidation problem again, right? In some ways, because you have a previous computation, you've already calculated something, and then you get new user input, and that kind of invalidates your previous cache. So I think incremental because as you said, it's incremental computation, right? I think incremental computation is a really interesting problem. And I think kind of like we as a discipline, we've gotten really good at this like batch processing thing, like you said, where you have some input at the beginning, and then you just you calculate the output and that's it, and your program is done. But this continuously new user input, that's in my experience where programs get really difficult to reason about. And then if you throw concurrency into the mix, it's even worse.
yeah. And, distributed system,
Yeah.
which everything is these days to some degree. Yeah, I mean, I think one of the things I do think a lot about is the debugging aspect, right? So it's not only a question of, how easy is it to use a certain paradigm to solve your problem in the first place. It's also a question of, how easily can you debug problems? When you make a mistake, how obvious is it where the mistake is? How much can you use kind of, binary search or some way of like cutting down the problem space? And many systems that are very powerful are actually also very hard to debug. CSS is, I think, a classic example of something that is extremely powerful if you know what you're doing. And I mean, I like CSS in many ways, but debugging CSS is very tricky, right? because you don't know how to cut down the solution space or the problem space, basically. I mean, I often resort to sort of going into the dev tools and unchecking box after box. I mean, I had this a few weeks ago that, I had, I don't know, 100 different rules or properties, whatever the right term is, right, that were being applied, and I didn't know which of them affected the thing that I cared about. I think, imperative programming is actually pretty good for this, because you can kind of identify generally, you can step through if you're using a debugger or print statements, you're kind of identifying a point in time where like everything is good now. After this, everything is bad. And there's a limited number of things you have to, at least in a well-architected system, right? There's a limited number of ways that you can transition from that good state to the bad state. And yeah, so just in general, I think sometimes we overlook how important the debugging process is, right? Many solutions look good until you have to debug them, and then they don't they don't have this property that you can kind of easily slice things to find out where things went wrong.
Do you think that's a problem with the tooling around it, or do you think it's a problem with the design of the language or the technology itself?
It's a little bit of both. I mean, I think you can certainly mitigate the problems with the tooling, right? But we've had, I think CSS is probably the best example, right? We have tools that have been developed for, 20 years now at least. Um, and probably billions of dollars sunk into the tooling, and it's still very hard to debug. Um,
That's what my initial reaction was at first too to what you said. I was like thinking, I was surprised that you mentioned CSS because I was initially thinking of tooling, but I actually think that the tooling, like I mean, the dev tools are they're amazing, right? They're really good, and you can like coming from other UI systems like on iOS or something. Like I wish I had some on iOS. I wish I had something as good as the web inspector.
yeah, I mean, certain types of problems are easy to diagnose, I'd say, right? But certain types are very hard. And one of the big things that happens, or one of the big problems I run into is, I have no idea why something is occurring. Um, if I think about the way it works in a step debugger, typically what happens is as long as you can kind of see, where things go off the rails, at some point you identify a statement or a function call or whatever that causes things to break, right? And then you can immediately zero in on that. Um, and CSS is lacking that, I think, apart from the sort of unchecking all the boxes. But there's also implicit dependencies,
That's
right?
yeah, exactly. The
Where
cascading part can really
it's,
bite you in the butt sometimes, right?
well, I think the cascading is not as bad because you can see I mean, if you know that the problem is with a given element, the tooling will show you all of the CSS that affects that element. But if it's something to do with a previous element or the parent element, um, then you're really in trouble because you don't know where to look, and there's no obvious way to kind of reduce the problem. Um,
hmm I think
yeah.
I think for me the worst situations with CSS are usually when there's a property that also affects a different property.
Hmm.
Like I don't know, you have something like this particular position attribute only works if the element also has, I don't know,
Well, it's like if you have,
a
say, top.
display of block or whatever, right? So
Yeah,
right,
exactly.
that kind of
Yeah.
thing, right? So you have two completely separate properties that and you just gotta know about that stuff, right? You just gotta know
Mhm.
that, well, you're not supposed to do that, right? And that's, to me, that's just a poorly designed API, honestly.
Yeah. This makes me think of, so, one of my projects is Ohm, which is this parsing toolkit for JavaScript. And this was something that came out of my work at my research on at CDG and Hark that I did after Google. And the first thing I worked on Ohm was the visualizer. And many people who use Ohm, when I talk to them and say, like, how did you find it? Are like, what do you like about it? What works well for you? What doesn't work well? The editor, the visualizer often comes up as a big reason that people really like it. And what we tried to do there, I mean, I will admit that it's maybe few people are able to unlock the full power because it's a very challenging problem. But one of the things we tried to do was to make basically the entire execution of the parsing algorithm visible and inspectable. And this is something that I've always thought I would like to see for CSS as well. So, there is stuff happening in the when your CSS, in the CSS layout engine that is not visible to you. And if you had some way of seeing that, right? If you could click on an element that, right now you can click on an element and you can see, oh, what kind of padding and margins does it have? Imagine if you could click on an element and see kind of a high level description of, all the calculations that took place that caused it to be placed where it is.
That would be
Um,
fantastic.
I think it's totally possible. I would, if I would attempt it, I wouldn't attempt it with full CSS. I would probably try to design some kind of mini CSS to demonstrate this. I think it's doable. So in some sense, I do think these problems can be solved with tooling. But it's like the sufficiently smart compiler. Sometimes the sophistication of your tool that your tooling requires is so great that maybe it's better ultimately to pick a simpler model that lends itself more easily to inspection and debugging, um, because the tooling is very hard to build and hard to learn as well, right? I mean, yeah, if you were going to have a really great CSS debugging tool, people would also need to learn that and would need to sort of understand the tool. Um,
But you see, I feel like I can't help but feel that when we talk about stuff like this, like I agree with you completely that a tool like that would be amazing. But I can't help but feel like, isn't that such a huge failing of our current languages and just the way that we currently do programming? Because at the end of the day, if you think about it, all the rules for how that box gets placed or that element gets placed, they're there, and they're probably even public. Like you could download the Chrome source code or whatever, the CSS engine. I don't know much about browsers, but like whatever, wherever the CSS engine actually is and lives, right? You could download that. You could go look at the source code, and you could get that understanding of how that box is placed by looking at the code. And like I understand what I'm asking is a big ask, but to me it's crazy that, or at least it seems desirable to me, that a regular programmer could open that up and just, be able to read the damn code and understand why it's working the way it's working. I think at the end of the day, the tooling is part of the story, because what does it take to do that, right? You would have to like actually find the repo, you would have to go download the repo, you would have to find the right place in the code and so on. It's like it's completely ridiculous to do this for just debugging the placement of one box. Um, but I think there's such a big gap there between how it could be. Like,
Yeah. I mean, Smalltalk, you could do this,
yeah.
right? Like
Mm-hmm.
in Smalltalk, you had sort of the whole system in a single uniform environment. And yeah, in theory, you would be able to go in and debug kind of any part of the system using the same tools that you use to debug your own program. Smalltalk had, you know, also had its problems, but that was one aspect which is really great about Smalltalk. Yeah, I totally agree that sort of the ability to, open the hood is kind of the analogy, right? Like on a car that you can, for the most part, you can drive your car and not care about what's going on the inside. But when it starts making a funny noise, you can open the hood and often, to some degree, diagnose the problem yourself. And our existing languages and tools make this very difficult. And I don't think it's fundamental. I think, I think it's a question of values. It's something that we could support if people really cared about it. In much the same way that, say, source level debugging is, something that we is basically ubiquitous, right? If you're debugging, you almost always, it's expected that you can see the original source code that was written, even if you're, executing machine code. And we've built a bunch of tooling around this to make that possible. Even JavaScript, right? You have source maps, WebAssembly, yeah. So if we had a similar culture around the ability to kind of open the hood on any arbitrary piece of code, I think we could make it happen. But I think it's just not what most people are concerned about, and it's sort of fallen by the wayside.
Yeah, I've wondered what's your take? Why aren't live environments like Smalltalk or stuff like that? Why hasn't that established itself more? Do you have any ideas?
Um, yeah, I mean, I have my own experiences, things that challenges I had with small talk, difficulties that you know, that give me some ideas. So, I mean, small talk, the kind of classic problems that people bring up with small talk. So, some small talk environments didn't really support source control. It was very hard to kind of like bring new code into the system. It wasn't true for all of them. So the system that I worked with, which was IBM Smalltalk, did have a source control mechanism and had good mechanisms for modularity. But yeah, it was generally sort of a closed world. And you see this still with, with JavaScript, with Rust. There are big benefits to having, one of the reasons I think people want to always rewrite things in Rust or rewrite them in JavaScript is you do get benefits from that uniformity, right? So if the code that you're writing is Rust and a library you're depending on is Rust, well, it's going to be easier for you to dive into that code and understand it. And I think Smalltalk had the same thing that if you had to interact with systems that were outside Smalltalk,
Gets really difficult. Mm.
yeah, you were kind of out of luck.
Hmm. Hmm.
Um, they also, a problem that Smalltalk had as well as the image-based model. It had its benefits, but also its problems, and it was very hard to kind of just restart from scratch. So on the team that I worked, there was a couple of people who were kind of experts in coming and bringing your image back to a good state.
Right, right.
And I mean, you still have these kinds of problems on like Unix systems as well. Like if someone came to you and said, "Oh, my fan is making really lots of noise. I don't know what's going on," you know, many people would know. Okay, I'm going to go to open up the terminal, run top,
Yeah,
like kill the process. You had to do that in Smalltalk as well. It's just that like I didn't personally know the right incantations to do what needed to be done. Um, so there was always someone you would have to go get to kind of like rescue your image if you hadn't saved it recently or something.
makes sense.
Um,
Yeah. Hmm.
yeah, and I mean liveness in general, I think, yeah, again, I don't know that it's not a fundamental. I think we could have it if people cared about it. Um, I think that it's just that many people don't see the benefits. I mean, I do think that there are kind of it's maybe a personal difference that some people really like this kind of dynamic way of working. So Jimmy Miller has a really good post about this. Discovery coding, that's what it's called. Yeah, I can send you the link. But it's this, yeah, I think some people like to work in a certain way where you kind of, you don't quite know what you're doing until you jump in and do it. And I think people who end up liking dynamic languages like that style of working. And I think other people are much more prefer to kind of plan a little bit more ahead of time and to sort of maybe move more cautiously, and maybe prefer a different style of programming that is, yeah, that is just incompatible with kind of liveness.
I think I disagree with you there because I think those are really two separate concepts. Like I think you could have a live environment that is very restrictive, that has like super strong type checking and like doesn't let you do many things that you could do. Like obviously Smalltalk is super dynamic, but I don't necessarily see why this has to be that way. I think you could have a small talky environment. Like obviously it would be a very different language, but you could have strong type checks. You could have, yeah, all these things that go more in that direction.
I guess it comes down to a question of what liveness means, right?
Yeah,
So one of the things you could do in Smalltalk was have a method which was not implemented. You could call that method. The debugger would throw an exception when the method got called, and then you could write the code for the method in place and continue from where you were. It's hard for me to see how something like that is fully
yeah,
compatible, with static type
yeah.
checking.
No, yeah,
Um,
absolutely. No, yeah, that's right. But I think like one example, fairly recent example that comes to my mind. It's really not a live environment at all. I guess maybe what I'm getting at is a more managed environment. So like I was thinking of Unison. Have you heard of that
yep.
language? Yeah.
Yeah. I haven't looked closely at it, but yeah, I'm aware of it.
Yeah. Because there you have basically you have all source code managed in a central database, or I guess it's a decentralized database, but like it's one database on your machine, and then that has a bunch of advantages. And I think, if I'm not mistaken, that is statically typed. Yeah.
Mhm. Yeah. I mean, I think you're right. You could do even in C++ or, Java with a debugger, you can do some form of live programming. So, yeah, you're right. They're not totally incompatible with each other. Um, but I guess what I was trying to get at was sort of there is this style of programming where you do sort of spend more time. Yeah, it's really hard to describe, I guess, but you spend more time sort of in the debugger testing things out. And so I remember once one of the, it's kind of funny, one of the sort of most pleasurable programming experiences I ever had was I was writing an app in Python on Windows with WPF, which was like one of the old, toolkits that kind of got deprecated. And but they had a version of Python for .NET called Iron Python. Um, and actually, like writing WPF apps in a REPL was actually a really great experience because
Okay, cool.
you'd have to figure out like what are all the flags to pass to make this window look the way, to make the button look the way I want it to look and stuff. And I would just always have this little test window open that I'd be like throwing widgets into and then kind of like fiddling with the properties until I got what I wanted. And then I would cut and paste the code from the REPL into my editor. And, that style I think it's not 100% incompatible with kind of static type checking, but it's very difficult to marry the two. I think you're going to be very limited because in Python I could create an object that has no properties, and then I can add the properties to it, and that gives you even just the fact that I could have a window open and I could continue to throw widgets into it, right, would be something which I don't think you could do in Swift, right? I mean, without resorting to like the sort of the dynamic escape hatches, anyways. That's
Yeah, that's what I was just about to say. I guess you would need to have, if you wanted it to be statically typed, you would have to have a lot of escape hatches, like you just have a lot of bunch of any's everywhere, and
right.
then at
Yeah,
some point
exactly.
you. But to me, that does sound like a promising thing to have like this, because to me, programming, I almost always program in phases. I have this exploratory phase where I don't care about anything, right? I just want to quickly iterate, and then at the like, and then I don't handle any errors. I don't do anything like
Mhm.
any kind of hardening. I don't write tests. I'm not a big believer in TDD. I I think that for many like there are some places where TDD makes sense if you have a very clearly defined function that has some input and gives some outputs, then it can make sense. But in a lot of cases, I think you got to figure out the structure of the whole thing first, and then it makes more sense to write tests. So I have this very exploratory phase, and then I go over to the okay, now I understand the problem. Now I know what I'm trying to do here, and now I'll actually start like hardening stuff and like adding types or making them nicer, the types, stuff
Mhm.
like that. So I think there's potential here for supporting this more gradual hardening.
Yeah, I agree. I mean, I think that was also supposed to be kind of the promise of TypeScript, right?
Yeah, yeah, yeah.
Um, in practice,
Yeah,
my experience has been it's actually not that easy to add the types later.
that's true.
Um, it depends. I mean, part of the problem is often you have an existing kind of development workflow, maybe that involves type checking, and you have to kind of ignore, red squigglies in your editor, potentially a
Yeah.
bunch of warnings at the in your terminal, which even though it's possible is kind of annoying, right? Like if you get to the point where you don't know whether the red squigglies are complaining about just, a missing type or whether they're complaining about an actual syntax error that you made, it gets a little bit tricky. But yeah, I mean, I agree also that this kind of notion of gradual typing or kind of gradual structure is a really powerful one and seems like the ideal. And I think, yeah, I mean, now that you mention Now that you mention it, right? So TypeScript is an example. TypeScript and JavaScript are an example where we have a language that supports static type checking, but is also very dynamic, right? So that is actually, a good example that, they're not, those two notions are not fundamentally, or sort of liveness and static checking are not fundamentally at odds.
Yeah. Yeah. It's the static checking is really just the I mean, some people say TypeScript is really just a linter at the end of the day, right?
Right.
In some
Yeah.
sense. Yeah. How do you feel about generative AI? How has generative AI affected programming and how will it change in the future?
By nature, I'm someone who is somewhat skeptical of kind of when there's, big hyped trends. So that was my initial reaction a few years ago, I guess, when people started using these tools for coding. But at a certain point, I realized, they are really, really powerful and are really useful for certain things. And so, yeah, I do use LLMs most of the time when I'm coding. My usage has changed over the years. Um, but in general, I feel like they programming is changing, and it's hard for me to imagine that we won't be using people. Most people won't be doing LLM assisted coding in 5 or 10 years. I am skeptical that it will be as revolutionary as some people think. The analogy that I keep coming back to is the internet. So I see kind of this whole AI, revolution as being similar to the internet, massively kind of life-changing, but at the same time, the full impacts will take a long time to be seen. So if you think that, widespread internet access happened in the mid 90s, and you could have said, if you were a naysayer back then, you would have said, oh, it's not that big a deal, etc. And, we're 30 years later and we're still seeing the impacts of it. So nothing changed overnight. I mean, stuff did change overnight, but at the same time, it took a long time to see the full impacts. Um, so I think that's kind of what's going to happen with AI. Um, I'm very convinced of the power of generative AI and programming. I am a little bit more unsure. I mean, I think I have a lot of concerns with generative AI in other contexts, and I'm a little bit unsure, sort of, I'd be afraid to make any predictions about you know, how it's going to affect other areas. I think to some degree it is especially good at coding or good for coding because um, we I mean, number one is programmers were used to reviewing code. We're used to kind of quickly looking at something and evaluating, is this anywhere near the correct solution, right? Like it's not that much different from using Stack Overflow, right? You Google your question, you look at some pages, and you do a very quick analysis of like, is this what I'm looking for or not? Um, so I think that for coding uses, yeah, it's a really good fit. For other uses, I'm not so sure.
Hmm. Hmm. How has it changed your day-to-day code? Like, do you use Copilot or Cursor or anything like that?
What I've been using is I use Zed as my editor, and I use Copilot, and along with Zed has like a chat panel and has inline assist, so you can select some code and ask it to modify that code. I've played with Cursor, I've played with Windsurf. Um, in the end, kind of, I found that what I got in Zed was the right balance for me. Um, I've also been exploring, I've used Claude Code, and recently I've been using Aider for certain things. And Yeah, I'm still kind of going back and forth on sort of, I'm not sure how much I really enjoy the agent stuff. It's a very different way of working. You spend a lot of time typing and giving instructions, and then a lot of time waiting. And I, for a lot of tasks, I prefer more of the inline assist because my brain stays a little bit more focused on the details of what I'm doing, and it feels a bit more like a um, slightly better autocomplete. Even when I'm getting it to, to rewrite big sections, it feels more like, okay, I could have done this myself, or I would have done this myself, and this just lets me like, skip over the commercials kind of thing, like just fast forward and get to the place that I would have gotten. Whereas the more agent-based workflows, I sometimes get frustrated by the amount of steering that I need to do.
Yeah.
Um,
Yeah.
and I'd rather sort of use a more precise, way of asking for help than to kind of have the LLM go off and write a bunch of code for me and then go through a bunch of rounds of correcting it.
Yeah. It's often hard to judge whether the back and forth with the LLM was actually worth it in the end. To me, at least, it feels like that
Yeah,
sometimes.
I'm often reminded of there's this famous article about written by, I think his name is Bruce Tognazzini, who worked on the Apple user interface research team. And they said that, back in the days of the original Macintosh, um, they did lab tests and people felt that it was faster to use keyboard shortcuts, but that it was actually faster to use the mouse for many
Really
tasks. Yeah.
interesting.
I don't know
Interesting.
how much this
Uh-huh.
holds true today,
Yeah.
but there was this basically this theory that, the fact that you're kind of your brain is actively trying to recall a shortcut and that if that things feel faster to you even if they aren't. And I sometimes have this feeling with the agent-based workflows that, it feels amazing. It's like, whoa, I didn't write any code, but you overlook the fact that you spent 20 minutes,
Writing the prompt
telling the
and
LLM
pre-prompting.
exactly.
Mm.
And I often find myself thinking, I think I might have been able to write this in the same amount of time that I spent writing the prompts.
The sad part for me is that very often, especially if it's a more difficult problem, when you're using the LLM, you still kind of have to understand the full problem, which of course is good. But then I'm not convinced that using the LLM is really the fastest way to get to that full understanding of the problem.
Yeah. Yeah, I find that somehow my focus stays in the wrong place. Uh, so I've noticed this also with debugging sometimes that it's sort of a difference I've noticed between printf debugging and using a debugger is when I'm using a debugger, I usually have to stop and think and form a hypothesis and then figure out, okay, how am I going to use the debugger to kind of confirm or deny this hypothesis or confirm or disprove this hypothesis. Whereas with print debugging, I sometimes find myself kind of just inserting print statements more and more and more, like almost getting lazy. And I just want like, the next one, just one more print statement, and hoping that eventually the answer will come. And
Shotgun printing.
yeah, and it's kind of like this with LLMs too.
Hmm.
Sometimes I find that I'm
Yeah,
getting more
I
and
know what you
more
mean.
sort of just come on,
Just give
just
me the
make it
answer.
better. Yeah,
Yeah.
exactly.
Yeah. I know exactly
Um,
what you mean. Uh-huh.
but I think like with the inline assist, I don't do that as much, right? With the inline assist, it feels like a much more surgical thing where I'm saying, okay, take this function, make the changes, and that keeps me engaged at sort of the right level. And so I think as much as I keep sort of trying out the agent-based workflows for certain things, I often come back to the inline assist as being kind of the sweet spot that you know makes me pay enough attention and forces me to understand enough about what I want done, that I really just get. I don't know if I get the best results or I just enjoy it more, or a little bit of both.
Definitely more surgical changes has been the best use of it for me as well.
Yeah.
And information retrieval. I think it's just I think honestly like that's to me is the biggest game changer in with LLMs. It's just this it's a really fuzzy search,
Hmm.
which I think is fantastic. Like I'm a note taker. I take a ridiculous amount of notes. Like it's part of my design process for most things. And so I am over the last 10 years or so, I think I don't know how much it is, but it must be hundreds of pages of notes in a big database. And a while ago I was thinking of this note that I had taken, and I kind of remembered roughly what I had written in the note, but only very roughly. And I just couldn't find it with the regular search. So then I just dumped the entire notes database into a text file. And I asked the LLM, like, I'm looking for a note and it kind of says this and this and this. And then I was able to find it. And that was just like, oh my God, that's awesome. Like that to me. And you can do the same thing with code bases, right?
Hmm.
That to me is one of the biggest values it provides.
Yeah. Yeah, I haven't yet got a good workflow for kind of pulling the right things into the context, I guess. I know there are some good tools for doing this that can kind of slurp up parts of your code base. But I personally don't have a good workflow for that yet. But that's a good point. I should try it on my notes as well. I mean, I'm not a crazy note taker, but I have, 10 plus years of notes on various things. And sometimes it's, notes about something I did to my web server 8 years ago that like be really handy to, and I often forget, where did I put that note or where did I write that down? So yeah, I'll bet I could make use of that.
Well, actually, you inspired me with we talked before about this, but you inspired me with your blog post about working in a way that lets you come back to a project. And for me, that really unlocked a lot of things. And I think that's why I'm such a compulsive note taker, because I like having like I write notes to be able to forget things. I don't want to think about these things anymore. And if I
Yeah.
write the note, then when I come back to the project, then I know exactly where I left off and I can just pick it right back up. So that for me was really helpful.
Yeah,
Do you,
that's nice to hear.
do you have any practical advice for current developers? Like, is there anything you've observed that people should stop doing or start doing or anything like that?
I think something that has really helped me was just sort of always being interested in learning new things. I've seen some developers who kind of they find the thing that they're good at and become a little bit over invested in kind of being the master of that area. And so I think I've always enjoyed, yeah, jumping into areas and it's good to feel comfortable being a beginner. It can be a hard thing, I think, you know, to do, to especially like the more experience you get to go into a new area and kind of be a newbie again. But I've gotten so many benefits from doing that that I would always encourage people to kind of yeah, to always be willing to jump into areas that they're not familiar with. And you never know kind of where the knowledge that you pick up will come in handy. But it often does. But I think that's to some degree, that's just that is a personality trait. I know people who are like me, like really enjoy kind of jumping into new areas. And I've also, I've managed people who I saw were much more interested in kind of staying in the area that they knew well. And I can respect both, you know, both ways of looking at the world, but I personally have always gotten a lot of benefit from trying new things. I mean, you do have to be selective. I always, the approach that I take is kind of a little bit like the way I do investing. So to kind of, try to build a balanced portfolio a little bit, right? So if you're going to spend a bit of time, it makes sense to spend a bit of time on something which may or may not be relevant in the future. Um, but you probably want to limit, if it's really speculative, then you probably want to limit the how deep you go down that rabbit hole. And so whenever I've invested time in learning things, I try to focus on the things where I think, there's a good chance that this is going to be relevant in 10 or 20 years. And I think that approach is even more relevant today when a lot of us are really unsure of what our jobs are going to look like in 5 to 10 years. I don't think there's a single programmer who does not have some kind of degree of discomfort not knowing, what's it going to look like in 5 to 10 years. And uh, I think there are still many things which in my mind are smart investments, regardless of what the future looks like. I mean, unless I sort of discount any prediction which says, programming is going to disappear, right? The AIs will be writing all the code. So anything at that far end of the spectrum, I'm not planning for. I don't want to make any predictions about whether it will or won't happen, but I don't plan for that. So I still invest time learning things like, you know, programming GPUs seems like a really great thing to know, right? Things like that. A lot of low-level programming concepts. I think currently we're seeing that, LLMs are great at writing React code, maybe not so great at writing garbage collectors and compilers. And, maybe that'll change. But I think understanding the lower level concepts has immense payoffs. And I'm pretty convinced that that's a good investment for the future, even if, yeah, even if LLMs are going to be writing more and more of the code. I think there will always be a place for people who understand enough of the technologies, right, to be able to diagnose. I mean, the things that we have to debug are just going to get more complex, right? If LLMs are writing more code, the problem solving is going to get even hairier, I think. Um, I mean, people might say, well, the LLMs will just do the debugging too, but I'm less convinced. I think that understanding the fundamentals is just as important as it was before. Um,
Yeah, I
so
agree with you. I agree with you. What's one thing that you would love to learn more about? You mentioned GPU programming before. Is that, yeah, I feel like that's something you're diving into now or have already
yeah, well,
dived into?
I spent some time last year diving into it really for the first time. I would like to go deeper on it. I was just thinking the other day whether I might write yeah, some sort of language that would maybe like an APL like array language that would execute on the GPU for, I don't know, image processing or something like this. So I would certainly like to deepen my knowledge there. I also have this book that I bought last year on computational geometry, and it's kind of all the kind of classic algorithms of computational geometry. And I would love to work through that. And these are both things, right, where I think I'm pretty convinced that this knowledge is going to be very useful over the next 10 to 20 years. So,
I've been eyeing web GPU quite a bit. I think it's really interesting and really cool.
yeah. So last year I was doing a project involving, I mean, we weren't sure whether we were building a desktop app, but we wanted to leave open the possibility that it would run on the web. And so the GPU programming that I was doing, I was using WGPU, which is a Rust library that is basically compatible with WebGPU.
Yeah, yeah, yeah.
And yeah, it was very nice. I also spent some time on that project looking at some of the other, you know, libraries, I guess. Like looking at Vulkan and looking at Metal, and Vulkan is one that's like mind-blowing how complex it is. So if I were starting with GPU programming, I would not be looking at Vulkan. I mean, I would probably either do Metal or Web GPU. Um, yeah, I think, but yeah, Web GPU is something. I mean, I've been debating writing whether I want to write a book. Because I just finished the book about WebAssembly, and now I'm thinking about whether I might want to do a book about Web GPU.
Cool, cool.
Yeah.
I'd love to read it. Tell me more about the WebAssembly book.
Yeah, so it's called WebAssembly from the ground up. And the idea is that you learn WebAssembly by writing a compiler that, for a simple programming language, that compiles that language down to WebAssembly. All the code in the book is in JavaScript, and we chose to do that because when you work in JavaScript with WebAssembly, it's really nice because you have kind of no layers of abstraction necessarily. Like there's not toolkits and frameworks that you need to deal with. What we actually start with is arrays, putting a series of numbers into an array that represent the bytes of a WebAssembly module, and then just loading and executing those. And then we build up from that basis. So there's sort of two things that you build up over the course of the book. One of them is a kind of assembler library that makes it a little bit more ergonomic to emit WebAssembly bytecode from JavaScript. So really just a bunch of helper functions kind of for creating the modules. And then we build up a very simple compiler for a language, and yeah, and then sort of the compiler uses the assembler library to produce a WebAssembly.
Cool. Yeah, you sent me a preview copy, and it looked really cool, very accessible. I think. And I really like that approach of starting out with a very simple compiler that basically, I think you had a compiler that fits in a tweet, right? A
Yeah, right. We have
WebAssembly
a blog
compiler.
post about that. Exactly. Yeah.
Yeah, that's
Um,
really cool because then you can really pretty quickly get to like seeing how it works and like actually running WebAssembly code on the compiler, which is really cool.
Yeah, so within like the first real chapter of the book,
Hmm.
you create your first WebAssembly module and execute it. So there's not a
Cool.
lot of overhead. There's not a lot of kind of time building up to it. We really start by taking the shortest route possible to making a working module in JavaScript. Yeah, and so I wrote that together with a friend, Mariano Guerra. Yeah, we've been working on it for about 2.5 years, and just had the official launch a few weeks ago.
Cool. Yeah, I'll link that in the description for sure.
Great.
Cool.
Yeah, it was a real experience writing a book. I've never written a book before. The closest thing I've had is did a master's thesis, and I've written a handful of academic papers. Um, One thing I didn't anticipate was, so it's a self-published book, and we decided to do it as an online book mostly. Um, And that meant that we had very few constraints.
Mm-hmm. Mm-hmm.
And I guess I didn't realize how nice it is to have constraints. So when I've written academic papers, right, you typically have a template that you need to follow and you have a page limit. And then there's certain conventions that your reviewers and your readers are going to expect. And you can play with those conventions a little bit. And one of the things in the papers that I've published, I've enjoyed kind of pushing the boundaries of, what you could do in an academic paper, whether that's trying to use more informal language or, on one of our papers, I spent just hours and hours trying to make the best possible visual representation of the algorithm. Um, so I think, you can push the boundaries in an academic paper, but the overall structure is pretty set. And when you're doing a self-published online book, anything is possible. Um, and
Which is a blessing and a curse, right?
Exactly. Yeah. And I think sort of over time, we ended up going, our original idea was to make something that was not so much to take as much advantage of the medium as we could. But over time, we found ourselves gravitating towards something that was much closer to a standard book than we expected. And in a way, it's not surprising, right? I mean, there's a reason books are the way they are. They've evolved over, however many hundred years it is now, close to 500 years, I think, right? Um, Kind of for good reasons. And there are a lot of benefits to that format. And yeah, that was surprising to me, though, was just, how much value I get out of having the constraints. And I think if I were to write another book, I would probably start by deciding what my constraints are and give myself a much more kind of constrained, yeah, much more structure from the get-go, and then try to work within that structure. And of course, you can throw it out, if you discover that something is just too constrictive, you can always throw that out. But I think we sort of did the opposite. We started with the view that anything was possible and slowly added back all the structure that you normally get in a conventional book. I guess I think there's this essay, The Tyranny of Structurelessness, if I remember correctly,
Oh, that sounds great.
um, which talks about this in an organizational context that, I think it was written in the 60s or 70s and was about, there was all these people who were kind of trying to reject formal hierarchies. And if I remember correctly, the essay kind of talks about how these hierarchies appear even if you don't have a formal hierarchy, they appear in these informal groups. And it's better to make the structure visible than it is to pretend that there won't be any structure.
Right.
Um,
Right. Ah, yeah, yeah. Hmm. That
and
sounds
then to kind of
familiar.
drive it underground and
Hmm.
have these hidden power structures. Yeah.
I think that's something you have anyways most of the time when you join a comp. Like to me, one of the most exhausting things is joining a new company because there's so many unwritten rules. Like on top of the written rules, there are so many unwritten rules that you have to learn, and
Mhm.
just figuring out those implicit structures is, I think, very, very it's a big challenge quite often now.
Yeah, absolutely. I mean, I think you're already sort of a step ahead of the game if you recognize that, right? Like I think for the first, I don't know how many years of my career, right? I didn't even see those things. And once you know that those things are at play and you're at least aware of them, then yeah, it makes it a little bit easier to navigate them.
Mm, for sure, yeah. Have you, because you already have quite a bit of experience in leadership and in management, is there anything interesting that you've learned there that you can share?
I mean, I think the biggest thing for me was that yeah, it sort of opened up this whole new world of concerns. So I think as an IC, there were so many things that just weren't visible to me. Partly because I wasn't looking. It's not that things were hidden, but just that my focus was so much on, the code and the architecture and things like that, that I really missed, all the things that all the people aspects basically. And so I really enjoyed when I made the switch to a manager. It was like, it's like discovering this whole new field or
World.
something, right?
Yeah.
Yeah, exactly, that you
Uh-huh.
sort of never paid attention to. Um, and it's sort of interesting that I became a parent around the same time that I became a manager. And it's in some ways it sounds bad to kind of draw that comparison, but um, it's in some ways it does make you attentive to certain things that you never thought about, right? You're often having to deal with emotions and yeah, a lot of problems. I think one of the first lessons I learned as a manager was so as an IC, when you're dealing with technical problems, sometimes you can just roll up your sleeves and say, you know what, screw it, I'm going to fix this right now.
Mm-hmm. Mm-hmm.
And when you're dealing with people problems, if you try to do things that way, you'll often make things worse.
Mm-hmm.
Is my experience anyways. So if you have people problems, and I mean, so much of what you deal with as a manager are people problems in one way or another.
Yep. Mm-hmm.
You just have to get used to the fact that, it's going to take you weeks or months to address something rather than a day or two or three.
Yep.
And so just getting comfortable with that slower pace of change and realizing that, yeah, you often make things worse if you try to fix things very quickly. If you say like, oh, I'm going to go talk to this person, this person, this person, I'm going to make them sit together and resolve their differences.
Mm-hmm.
You often end up with people sort of more upset
Yep.
than they were before.
Yeah.
And so learning to use a sort of light touch and learning to just be patient and let certain things take their time.
Mm-hmm.
That
Mm-hmm.
was a big lesson for me.
Mm-hmm. Yeah, I can. Mm-hmm. I can relate to that. Yeah. Yeah.
And yeah, I mean, I think what I learned as a manager also comes in very valuable as an IC, when I've joined new teams, because I think, yeah, it made me much more attuned to how important the relationships are and made me look for certain things that I previously, if I were joining a new team, I might have been entirely focused on, yeah, okay, let's look at the code, how does it work, etc. And now when I join a new team, whether that's as a freelancer or, when I joined SourceGraph, say, um, in all those instances, I'm much more thinking about, the people, the organization, um, things like that.
Yeah, for sure. I mean, it definitely helps as an IC if you have a better understanding of what your manager needs or what they are going through, what they're experiencing.
Yeah.
Just helps if you have empathy for them and really can understand what they go through. I mean, there's so many things, like you said, right? There's so many things that as an IC you just don't notice, right? Like people people who threaten to quit, and then you have to deal with that, and because those are things you don't hear about, right? Because
Yeah.
obviously nobody wants to talk about this. But as a manager, you have to deal with it, right? So
Yeah.
yeah. Mm,
Yeah. Or, people are maybe working on something that they're not really excited about, and they've told you
mm,
about that, but it's really important to the team, and there's no one else can
mm-hmm,
do it that can do
mm-hmm,
it. Right. You have to know sort of as a manager, okay, I should cut this person some slack because they're doing something that, no one else on the team wants to do and can do.
Yeah.
But their teammates may not really be aware of that. So there's a
Mm,
subtle, yeah, there's some subtleties there that when you're an IC, you may not be aware of. And
mhm.
certainly, I think when I became a manager and I kind of look back then on things that had happened earlier in my career, I mean, I certainly have moments where I think, oh God, if I were my own manager, like like I would have been upset as a manager at the
I
way
think,
that I
yeah, I think we all had those moments at some point.
um
Patrick, I think that was a really fun conversation. Thanks for the chat.
thanks. Yeah, I've enjoyed it as well.
Yeah. Thanks for taking the time. I will link your book in the description for sure. Go check it out. I think it's a really cool book. Very
Thanks.
accessible and but still goes into depth. So I think really worth your time. And yeah, thanks so much, Patrick. Was really great.
Yeah, great talking to you too.
All right. Thanks. Bye.
Take care. Bye.